So if you can define two different functions being divided, like if I call the entire numerator f of x and if I call the entire denominator g of x, then you have a situation where the quotient rule of differentiation can happen. Okay? And the quotient rule of differentiation, remember the y prime means the derivative, is found by taking the derivative of f times g, subtracted by f kept the same times the derivative of g. And that's all over g squared. Okay, and if you know the product rule, you could easily derive the quotient rule. But okay, so that's the quotient rule. We just need to plug in some algebra in for the derivative of f. Plug some algebra in for g of x. Plug expressions in here, and then we've got our derivative. We just might need to clean it up. So we called this f of x. So the derivative of f with respect to x is 2x plus 5. And I got that by taking the power rule. The 2 comes down and multiplies to make 2x. The 1 comes down and multiplies to make 5. But now there's no x here, right? Because if the 1 comes down, you always have to reduce the power by 1 when you're using the power rule. So x to the 0 is just 1. So that's why that's the derivative. And the derivative of g of x, the 2 comes down and multiplies. Then the power gets reduced by 1. So we just have to plug that stuff into the quotient rule formula, sorry. So 2x plus 5 goes in for the derivative times g, which is x squared. So I've done this so far. And then we've got f of x, which is x squared plus 5x minus 1. And then times the derivative of g, which is 2x. That's all over g of x squared. So my g of x was x squared, but then that's being squared. So there's two squarings going on there. Okay, that's it. That's the derivative. It's just ugly right now. We just got to clean it up. Okay, so we can distribute that x squared to everything inside. That makes 2x to the third plus 5x squared. And then watch out here. That's a minus sign in front of parentheses. So when you distribute that 2x to everything in here, keep it all in parentheses to remind yourself that you've got to distribute that minus sign. Okay, and then now we can start combining like terms. I've got 2x to the third. I'm going to be subtracting 2x to the third, so that's going to cancel out. Let's see, I have 5x squared minus a 10x squared, so I'm going to be left with negative 5x squared. And then minus a negative 2x, that's plus 2x in the numerator. So I can clean it up a little bit more by factoring out an x from the numerator. So that's going to be x parentheses negative 5x plus 2 over x to the fourth. And the whole reason I did that is because you got an x in the top and 4x's in the bottom. One of those in the top and the bottom can cancel out to make x to the third. Let's see, I think that's it. Checking out the textbook. This is the correct answer. Another way of writing this answer, though, is to break it up into two separate fractions like this. This is equivalent, right? I divide negative 5x by x to the third. I divide 2 by x to the third. And then if you do that, this fraction can simplify. I don't think it's clear that this is a simpler answer than the other one, though. Plenty of times you'll see textbooks leave it like this. So that's fine for me. This is also fine if you break it up.